All right, hello folks. So very exciting news. This is our last lesson of statistics for the semester, and it's mostly just an opportunity to review some of the concepts we've learned so far in the context of how they appear in the media or in politics, which is of course very timely this week. That worked out well. And so there's nothing really like new material here. And so because of that, there isn't a classwork or anything this week. This is just a relatively short lesson to help us kind of see how some of the stuff we've done so far translates into the real world. And then just to, make sure that you watch this whole video. The only homework assignment for this week is just a quick 3-question multiple choice quiz on Canvas. So there's nothing that you submit beyond that for the homework this week either. And then the next 2 weeks after this week, to wrap up the semester, we have 1 week devoted for project number 2, so stay tuned for that. And then the final week is for the final exam, and we are done. So you guys should really give yourselves a pat on the back. I know many people come into this class with great fear and anxiety about statistics, but you guys have done a kick-ass job, and we are now in the home stretch. All right, so let's talk statistics in the media and politics. So I have one example here. It's from a newspaper that looks at the average amount that Americans read in any given year. So this chart here shows the means and the medians among different demographic different demographic groups for the number of books that they have read in the past 12 months. So among all adults, the median number of books that somebody's read in 12 months is 4, whereas the mean is 12. And so when we look at all of these different demographic groups, whether it's for gender or race and ethnicity or age, income level, education level, geographic location, whatever it is, you'll see that for all of these, the mean is a lot higher than the median. This is helpful for us to remember, though. What's the difference between the mean and the median? What do you think might account for such a big difference in the mean and the median? Why is the mean so much higher than the median? And if we think about this, we know that the mean, both are measures of central tendency, right? Both seek to say what's the one value that best represents or summarizes all values in our data set. But the mean is very sensitive to outliers, right? That if there's a really extreme score, that's going to pull up and make higher the mean. Whereas the median is simply the middlemost value. So it doesn't matter if there's a lot of really high values at one end or low values at the other end. It's not sensitive to outliers in the same way. So thinking about this in the context of how much people read, this makes sense because we know some people are just like voracious readers and read 100 books or more in a given year. And so those few people who are, professors in particular, I read a ton in every year. But so there's the few people who read a whole lot that are going to pull up that average if we're calculating the mean, right? Because they're outliers. Whereas the median, if it's just the middlemost value, that shows perhaps a better or more accurate representation of how much most Americans read. So the mean is so much higher because we know some people are just super readers and read a ton of books every year and are outliers. But this is one example of if you saw this study in a newspaper article, you would be able to say, I know the difference between a mean and a median, and I know why the mean is so much higher than the median. It doesn't necessarily mean that on average Americans read this many books, but that there's a lot of people who read 100 books a year, 200 books a year, and so that's what pulls up the mean so much higher. Okay, this next example is just a section of an article that's from a popular news magazine called The New Yorker. That's a really great publication. by actually Malcolm Gladwell, happens to be a sociologist, but he's writing about what happened after Katrina, Hurricane Katrina, when victims left New Orleans. And there's this one part in particular that I think is helpful for us to make a connection to standard deviation. So remember, standard deviation being our main measure of dispersion that seeks to look at how spread out values are, and that we also talked a lot about standard deviation in the context of z-scores and the area under the curve and all of the characteristics of a normal curve. And so I want you to, and it looks a little faded, at least on my screen here, so I apologize, but jumping ahead, this bottom part here that's highlighted says, more people had jobs, their exposure to concentrated disadvantage, an index that factors in several measures of poverty, fell by half a standard deviation. And so if you read that, it doesn't say like, what is the mean or what is the standard deviation for concentrated disadvantage? But what we know is that even without knowing the actual value of the standard deviation, falling by half a standard deviation is a pretty big change because of what we know about the normal curve, right? Remember, always, 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 if it's a normal curve, 68% of all values are within one standard deviation of a mean. So that if a measure like concentrated disadvantage fell by half a standard deviation, we know that's a pretty substantive, pretty big chunk, right? So here's a circumstance in which you were reading a news article and it didn't actually say what the standard deviation is, but one example of how standard deviation can just come up in the popular press, and now you know what that means. To fall by half a standard deviation is a pretty big deal because of what we know about the area under the curve. Okay, here is, this was actually done as a study to assess people's quantitative literacy skills. So that means how good can they look at numbers or graphs or charts and understand what it's actually trying to say. And so this type of chart is one we look at a lot more when you take Soc 302 next semester for inferential statistics, but this is called a scatter plot. And a scatter plot shows the relationship between two different variables. And what's interesting in this study is that only 63% of American adults could properly read this chart and make the correct conclusion. There was, of course, really interesting differences based off of education level as well, so that we knew that 8 out of 10 people with a college degree could read it correctly, but only about half of people with a high school diploma could read it correctly. So I would ask you to pause for a second, take a look at the chart, and see if you would identify A, B, C, or D as the correct answer. If you fall into that 8 of the 10 college educated people who would read it correctly. So take a pause real quick. All right, so I'm hoping that many of you would select C. The correct answer for this one is C. The more sugar people eat, the more likely they are to get cavities. And so if we look at this on the chart here, this first one is sugar consumption, right, along the x-axis at the bottom, and the one along the y-axis here is the average number of decayed teeth. So this is a person here, for example, who eats lots of sugar and has a higher number of decayed teeth. Here's people who eat very little sugar and have lower numbers of cavities, right? So that we see this, what we'll talk about in 302 is called the slope of the line, shows that as sugar consumption increases, the number of cavities increase as well, that there's a correlation that these variables are moving in the same direction. So again, just another example of statistics in the media and in real life, and how your comfort with these types of concepts should matter. All right, here's one for us to be able to practice and think about a little bit, this idea of false positives and false negatives, type 1, type 2 error. And so this, and also issues of statistical significance. So this blurb describes this study that was done by a psychologist and 2 of his graduate students. that they looked at people's ability to differentiate shades of gray. So they would give them this image that had like black at one end, white at the other end, and all of these different shades of gray in the middle, and would ask them like, okay, are these ones in the middle, are they actually different or are they the same color? So that's what it means, like differentiating different shades of gray. And they also asked people about their political affiliations. Were they more Republican and right-leaning, or were they more liberal and left-leaning, or somewhere in the middle? And what they found in doing this study with 2,000 people was that people who were moderates on the political spectrum, so kind of fell in the middle between liberals and conservatives, more accurately perceived these various shades of gray than people on either extreme of the political spectrum. Their analysis showed that the differences were statistically significant with a p-value of 0.01, so that's even less than the p-value of 0.05 that we practiced as our level of statistical significance. And thus, because they had a low p-value, that means they rejected the null hypothesis, right? Their null hypothesis would have been something like the rate of shade identification among liberals, moderates, and conservatives is equal, but they actually found, right, that moderates more accurately predicted shades of gray, so they would have rejected the null and said there is a difference between groups because their p-value is less than 0.05. And thus concluded that political extremists, people totally liberal, totally conservative, perceive the world in more black and white terms, both figuratively and literally, right? Kind of seems like a crazy idea, but this is what their study results found. Turns out, a p-value that low, the result hardly screamed false positive. Remember, false positive meaning that you found a difference between groups. You rejected the null hypothesis when really it should have been accepted. But the usual step, this is where science is always, the need for replication of studies is so important, because after it becomes reproduced, they did it again, other researchers did it again, and they found that this is obviously not the case, right? That there's nothing to think that your political affiliation can actually influence something about the way you distinguish colors. That's ridiculous. And yet here's an example of a study that every once in a while, even with a p-value of 0.01, that means 1% of the time we're going to get it wrong. We're going to make the wrong conclusion. And so this is why we should never really give too much weight to any one study, that we need replication, we need similar studies to be done over and over again, because even with a false positive or a type 1 error, right? Type 1 is rejecting the null when we should have failed to reject or accept it. This is always a possibility, right? But so here's an example that comes up that came up in the news about these good study that was well done, and they had a really low p-value of 0.01, and yet still this happens to be a false positive. Okay, confidence intervals. This is the last thing we did. The biggest way that you are going to see confidence intervals play out in the real world is with polling. So we'll look first at this example of a poll that's from the Gallup poll, is one of the largest nationally representative polls that's done, and then we'll look in particular for presidential polling for the upcoming election is really important as well. So remember, a confidence interval gives us the best estimate of a range of a population value given what we know about that value in a sample. So remember, anytime we are trying to draw conclusions about an entire population and we're using a sample, we want that sample to be as generalizable and representative of the population as it can be, but we know there's always going to be some level of sampling error, right? Sampling error is the difference between what our sample says and what actually exists in the population. And so a confidence interval helps us be able to say, for any value that our sample has, how different might that value be in our population? And so, for example, this is from the Gallup poll question that asks, how much confidence do you have in the police? And people responses who said a great deal of confidence or quite a lot of confidence are charted here over time. And so this is, for example, the Gallup poll is done on telephone interviews with a random sample of 1,500 adults over the age of 18, all 50 states and DC. And the margin of error here, that's your confidence interval, is plus or minus 3 points. And so when we hear things in political polling or in polling like this, plus or minus 3 points is essentially saying any value in the sample could be 3 points higher in the population or 3 points lower in the population. So if their sample here for 2015 said 52% of people said they had a great deal or quite a lot of confidence in the police, in reality, in the population, this value could be 55, 52 plus 3, or it could be 49, 52 minus 49. So that kind of gives us the range for what it might actually be in the population. It could be as low as we're 95% confident that it's somewhere between 49 and 55. And so if we ask the question about, can we conclude, considering this margin of error, can we conclude, for example, that there was this like huge drop from 2013 to 2015, from 57 down to 52? The answer is no. We shouldn't really make too much of that because of the 3-point margin of error, right? This 52 could really be anywhere from 49 to 55. This 57 in the population could be anywhere from 54 to 60. So it's totally possible that in the population, confidence in the police did not change at all because of our 3 points margin of error. Just as an FYI too, I use this graph just because it shows, I think it's interesting to look at historically over time. I haven't seen a graph that includes the more recent Gallup poll numbers, but just as a heads up, the numbers for 2019 were 53%, and the numbers for 2020 were 48% in the sample. Again, once we look at that 3-point margin of error, it's hard to draw conclusions about a really big change in confidence in the police. All right, now, very timely and relevant if we're looking at confidence intervals or the margin of error in presidential polls. So I just pulled this up as of Friday. This is from a website called 270-WIN. That the 270 is the electoral college votes that a presidential candidate needs in order to secure victory. So I strongly recommend this website for lots of presidential election information, called the numeric 272 to2win.com. But this compiles a bunch of the recent presidential polls that have been done. So for example, it shows the date that it was done, the sample size. So this one was among 959. LV stands for likely voters. And then this plus or minus is the margin of error, or you can think of this as our confidence interval, how much we think each value in the sample could be off by. And note here, what's interesting is that the margin of error goes down as the sample size goes up, right? If our sample is larger, we can have greater confidence that the population is closer to that sample, right? So you'll see here that, for example, the one that had a sample of 150 likely voters, the margin of error is 3.1, compared to the one that has 16,000 some likely voters, the margin of error is only plus or minus 1. That these guesses then these estimates then are only off by 1 percentage point in either direction. So this really shows how much margin of error is important. Margin of error for political polls is usually around 3%. This gets into statistical sampling techniques that are way beyond what we do in this class, but they also factor in something called weighting, so that if they're able to sample people from one segment of the population more, they can weight the sample to be more representative of the population. I say that just as a disclaimer of that it's not just sample size that influences margin of error, but there's all these other measures of representativeness that get done in this really sophisticated statistical modeling as well. But in general, I think you can see that as sample size goes up, the margin of error goes down. But so if we're interpreting this, let's look at perhaps the one from Hofstra University on Friday. This is from 2,000 likely voters. Well, for ease of doing the math on this, this is a margin of error of approximately 3%. So that means that the percent supporting Biden could be anywhere from 51% to 57%, and the 1% supporting Trump could be anywhere from 40% to 46%. When we consider the margin of error, suddenly this doesn't look like such a big difference, right? This drives me crazy as a statistician, watching all of the political polling that's shown in the media that makes it look like, you know, one candidate, and this isn't just for this presidential election, but for any election, looks like one candidate might have a really big lead. Well, when we consider the margin of error, that Biden could be, for this one, as low as 51 and Trump as high as 46, just in this one, obviously some of these are even closer, then it doesn't look like it's clear that one is a lot larger than the other. I think, and we saw this after the 2016 election with President Trump as well, that there's a level of what's called in survey research called social desirability bias. It's much more likely that people do not want to admit their support for President Trump than it is for Biden, for whatever reason. But we saw this after 2016, that there were a lot of people who did not want to share their support for Trump. My expectation, and other political analysts have said this as well, that we would expect that trend to continue. So even though this looks like a big difference now, once we take into account social desirability bias, and most importantly, at least for the context of our class, margin of error, these are definitely much closer than they might appear, or at least what's portrayed in a lot of media depictions. Okay, and so, you know, I have to use this as my opportunity to say, if you have not already engaged in early voting, you haven't mailed in your ballot, or done some other form of early voting, make sure on Tuesday you go to vote. It's critically important. Please, please, please vote. Okay, last slide is just another visual representation from a media publication that shows confidence intervals as well. This is also always my opportunity to point out that driving is statistically probably the most dangerous thing any of us do on a regular basis in life. So always practice safe driving, but that this shows the confidence intervals for what percentage of people who die in a car crash. So motor vehicle crash deaths per 100 million vehicle miles. So this takes into account how often people drive. Obviously, people who drive more miles on average in a year have a higher risk of dying in a car crash than somebody who does not drive very often. So this takes into account deaths per miles driven for people aged 25 and older. And we see some pretty significant differences or substantial differences based off of their level of education. The shading part shows what those ranges are using a 95% confidence interval. So for example, as of 2010, there's 7.5 deaths per 100 million vehicle miles for people with less than a high school education. That's based off of the sample, but in the population, that could be as high as 10 or as low as 5. Then there's the shading ranges around these other values as well. So this is just another example of confidence intervals being shown in popular media that now you know what that means as a result of this class. Okay, so that's it. I hope this gave you an opportunity to practice some of the things we've learned this semester, see how they play out in the real world. Just to prove to me that you listened to this entire lesson, do the, should be an easy 100% on your homework for this week. There's a quick 3-question lesson quiz for your homework this week based off of this lesson. Send me questions or comments if you have them, and then I will see you next week for us to get started on project number 2. Have a lovely day. I'll talk to you guys soon.